Welcome to the Deep Dive. Today, we're not jumping through stacks of articles. Instead, we've got something really special, a single fascinating source.
We do. It's a set of letters written way back in the 18th century.
And now it's preserved as this digital time capsule. So our mission today is to really get to the heart of the scientific and philosophical ideas of that age, all delivered to us through this incredible, modern mechanism of digital access.
That really is the beauty of this. I mean, we're holding a digital file, but what it represents is a book that sat on a library shelf for, hundreds of years?
Wow.
It's a literal gateway. These mass digitization projects, they give us instant entry into these original debates on physics, on astronomy,
Yeah.
and philosophy, right when these foundational laws were still being hammered out. So that's really the core conflict we're exploring today. It's this collision. You've got the 18th century mind trying to calculate the infinite, and it's delivered to us through 21st century tech.
Tech, which has its own very strict set of rules. Exactly. So we want the absolute best nuggets. What this book says about the universe and what its very existence says about how we look after knowledge today.
It's a dual narrative, for sure. I mean, the book itself only survived long enough for its copyright to expire. And because it expired, it's now in the public domain.
Which is the only reason we can access it so freely. That status is everything. And when you open this digitized volume, you can immediately tell it had a life before it was a file.
Oh, absolutely. It's not a sterile, clean text.
No. You see the blemishes, the little marks, notes in the margins.
And you can even see the library infrastructure itself.
That's what I was going to say. The NYPL Research Library barcode is right there on the scan.
Yeah, it's captured forever. It's a reminder that this knowledge came from a specific, tangible place.
It gives the whole file a sense of, history, real story.
Right. And, because digitizing and maintaining these works is so expensive, Google has kind of stepped in as a custodian.
A temporary custodian.
A temporary custodian, yeah. And that's why, even though it's in the public domain, there's a whole framework for how you can use it.
Right. They can't stop you from reading it, of course, but they can set terms for how you handle the actual digital file.
Mm-hmm.
If you boil down all of the guidelines they provide, there are, I think, two main things for the average learner to keep in mind.
The first one is really about attribution and integrity. They need you to keep that Google watermark visible on the pages.
It's their way of saying, we did this work.
Exactly. They
Yeah.
digitized it, and they need to make sure the work stays non-commercial. It's meant for individual use, not for someone to just repackage and profit from their labor.
And the second point, which is way more complex, is the legal side of things.
This one is tricky.
Yeah, they explicitly warn you that just because they in the United States see the book as public domain, that doesn't mean it is everywhere.
Copyright law is local. It's not global.
So the moment this digital file crosses a border, you are responsible for checking its status in your country.
Which is a striking reminder that even global knowledge is still bound by these very complex local laws.
So we're starting with this modern mechanism, a file governed by rules of custody. And now we can pivot to the rules of the cosmos as they saw them 200 years ago.
Let's do it. Let's jump straight into letter 59. It's an attempt to literally map out the system of the universe.
What's so fascinating here is how fast they move from just looking up at the sky to thinking on a massive scale.
They're not messing around.
No, they correctly identify that the fixed stars.
The ones that don't seem to wander.
Right. They realize they're luminous, just like
Yep.
our sun, and they are obviously at a tremendous distance from Earth and from each other.
And their hypothesis from there is just incredibly confident. They say, look, each one of these fixed stars is probably of equal magnitude to the sun itself.
Which is a huge leap. But the real moment of awe, for me, comes when they actually put a number on that distance.
This is where it gets mind-blowing.
It really is. They state, flat out, that the nearest fixed star is at least 400,000 times more distant than the sun.
Can you just think about that for a second?
It's staggering.
In the 18th century, with no advanced optics, no modern parallax measurements, to confidently state a number like that, 400,000 times the Earth-Sun distance.
Even if the number isn't perfectly precise by our standards today.
That doesn't even matter. It demonstrates this profound faith they had in math and geometric reasoning to unlock the secrets of the cosmos.
It must have just shattered any lingering ideas of a small, Earth-centered universe.
Completely. And if these fixed stars are suns, well, the next question is obvious.
What are they illuminating?
Exactly. The text suggests they must be communicating light and heat to certain opaque bodies.
Which we would just call planets.
Right. Planets that are similar to our own Earth.
And this leads them straight into philosophy, doesn't it?
It does. It's the next logical step for an 18th century thinker. If there are other planets like ours,
Then they must be inhabited.
they must undoubtedly be inhabited, is the quote. Although the letter is quick to add that their prodigious distance makes it impossible to ever confirm.
So in this model, our sun's main purpose is just to warm the Earth and the other local planets. It's a design of infinite parallel systems, just stretching out forever.
A truly grand design. A clockwork cosmos.
Okay, so we've established that grand design. Let's snap all the way back down to Earth and look at a mystery you see every single time you step outside. The color of the sky, or as they call it, the azure color.
I love this part. It is a perfect demonstration of their mechanical worldview, but applied to something terrestrial.
So where do they start?
Well, they already understood that the stars are still up there during the day, but their light is absorbed by the air. That's why we can't see them.
Okay, that makes sense.
So that leads them to the cause of the blue color. And they say it's found in the transparency of the air itself.
Wait, if the air is transparent, how does it have a color? That seems like a contradiction.
It does, but they quickly clarify that it's not perfectly transparent. They argue that the air is loaded with a great quantity of small particles, just tiny little motes floating around, illuminated by the sun's rays.
And this is where their mechanical explanation gets really ingenious, isn't it?
It's brilliant. They propose that when these tiny particles are struck by sunlight, they receive a motion of vibration.
So they're physically vibrating.
Yes. And this vibration produces entirely new rays of light, rays that we can actually see.
Wow. So they recognize that the light we see from the sky isn't just sunlight passing through.
It's light being actively re-radiated by these countless little particles.
And they say the color of that re-radiated light is blue or bluish, but they describe it as extremely delicate.
Right. So if each individual particle is only giving off this faint, delicate color, why is the sky so deeply blue?
It has to be about the sheer quantity, right?
Exactly. It's purely a factor of volume.
Huh.
The delicate color is only visible because we're looking through an enormous mass of air.
That's the key.
It is. If you try to observe the air inside a room, you see nothing. There's no blue color.
But when you look up, the cumulative effect of, I don't know, trillions upon trillions of these tiny vibrating bluish particles.
The sheer volume of the atmosphere, it all blends together into that deep blue we see over our heads.
And they back this up. They corroborate this idea with a really beautiful example from the natural world.
They do. They ask you to just look at a forest from a moderate distance.
What happens when you do that?
Oh, well, the true color of the leaves is green, obviously. But as you look at it from farther away, the forest starts to get a bluish tinge.
And it gets deeper and deeper blue the farther away you are.
Exactly. The green light from the leaves has to pass through more and more of that air with all its particles, and that air adds its bluish cast on top.
It's such an elegant, everyday observation that just perfectly confirms their theory.
It does. And it's important to remember these letters weren't just text. They often included these incredibly detailed diagrams, geometric constructions, figures showing lenses and light rays, to really solidify this mechanical worldview.
So we've covered the cosmic mechanics and the terrestrial mechanics.
Yep.
It all seems to run on these fixed, predictable rules.
A perfect system.
Which brings us to the deepest question of all. The metaphysics of destiny and free will.
Right. We're moving to letter 88.
And the question is, if the physical world is a predictable machine, how do human events fit in?
This is where they try to categorize everything. The letter defines two fundamental types of events that happen in common life.
Okay, what are they?
First, you have natural events. These are produced by purely physical or corporeal causes. Men are passive observers.
So like a natural disaster, an earthquake, a tempest.
Or even a tree being torn up by a strong wind. Humans aren't actively involved.
Okay, so that's category one. What's the second?
The second is where it gets a bit murky. They're called moral events. These are still produced by physical causes, but they're causes in which human beings cooperate.
So using the same example, it would be a tree torn up by the deliberate muscular strength of a person.
Precisely. The key difference is the involvement of the human will.
And the model they use to connect all of this, from the cosmic scale down to human choice, is the universe as a machine.
A comprehensive machine. The text literally compares it to a perfect synchronized device.
The mechanism of a watch, I saw that.
Yes, where every single component operates according to a fixed primitive plan that was laid down at the very beginning of time.
But that's the great paradox, isn't it? If the universe is a perfect, deterministic machine, a watch, then what about human liberty? How can we have free will?
And this letter, dated December 23rd, 1760, tackles that paradox head-on. The paradox of divine providence versus human freedom.
What's the answer they come up with?
The synthesis they arrive at is, well, it's breathtakingly bold. They argue that God maintains absolute sovereignty over all events, notwithstanding the liberty of men.
How is that even possible? It sounds like a complete contradiction.
It does, but they resolve it by suggesting that all human actions, even our freest choices, were already part of that original primitive plan.
So our choices were built into the machine from the start.
They were accounted for when God first created the universe. Our liberty isn't some external variable that causes chaos.
It's just the most intricate, complex gear inside the ultimate clockwork cosmos.
Exactly. And the text doesn't present this as a confusing puzzle. It's presented as a source of awe.
Right, it says the reflection plunges us into an abyss of wonder and adoration at the infinite perfections of the Creator.
To the 18th century mind, this was the ultimate sign of perfection. A fully deterministic universe where human freedom still exists perfectly within the design.
That is just an astonishing journey. We started with the very modern rules of digital access, the friction between global knowledge and local law. And we traveled all the way back to the grand theories of these 18th century thinkers. They were grappling with the scale of the cosmos, finding this incredible ingenuity in just the color of the sky.
And then trying to fit the messy concept of free will into a perfect deterministic watch.
And I think that's the real takeaway for you, the learner. These preserved letters are so much more than history.
They show that the fundamental questions about the limits of our knowledge, the relationship between cause and consequence, they're truly timeless.
They're gateways to the past that really help clarify the present.
Absolutely.
The power of their worldview was so rooted in this idea of the universe as a perfect, knowable machine. So here's a final thought for you to consider as we wrap up. If those 18th century scientists saw the entire universe operating like that perfectly synchronized watch, what kind of machine would they compare it to today?
That's a great question.
Given everything we now know about quantum uncertainty, chaotic systems, the emergent complexity, what would their metaphor be now? Something for you to ponder as you reflect on the ultimate design of the universe. We'll see you on the next deep dive.